Hi, I'm Ruben Sakrabani from Cranfield University, and I am pleased to present the scoping study, which is on feasibility studies on using neutron and Raman spectroscopy to evaluate physical and chemical characteristics of novel green fertilizers. The food challenge that I'm trying to address in this project is basically touching on the food security, in particular focusing on the fertilizer component. As you can imagine that this is obviously a very key part for crop growth and food productivity because of also on the current challenges that we have, such as the pandemic and also changing weather patterns. Conventional chemical fertilizers are the main source of fertilizers used, but they are very energy intensive. And as a way forward to encourage more sustainability, we have embarked on this exciting project where we are capturing CO2 from the atmosphere into food waste and then converting it into a fertilizer to provide an alternative source of a novel fertilizer with the aim of looking at its potential to sequester carbon in soil. So this is also very timely in terms of policy, from the policy perspective. But one of the key things that we are focusing, the novel approach, is to look at how we can utilize SDFC facilities to look at traceability of these organic fertilizers. As you can imagine, as opposed to chemical fertilizers, the organic fertilizers are very inherently variable, and that's why the traceability is important. And this is where the SDFC facilities come in very handy. And we are using the neutron tomography and the spatially offset Raman spectroscopy to look at two components. The neutron tomography will be focusing on the physical side of the characterization, which is looking at porosity and structural composition of the fertilizer pellets, whereas the Raman spectroscopy, we're looking at the chemical composition, chemical bonds in particular. So in combination between these two techniques, we will be able to get the physical and chemical properties of these pellets. And by using these information, we are hoping to develop an algorithm that we can use to then get a measure of the traceability of these fertilizers. Now, why this is important is because, as I mentioned earlier, the organic fertilizers are very inherently variable due to its biological origin. And these traceability based on this algorithm will give an estimate on how variable it is between batches, so we can use it with confidence. And we are also hoping to take this forward with future projects, such as the one that we have applied for with BBSRC for the Food Biosystems PhD project, and also hoping to publish some short communications in journals and develop further funding from the UKRI using the SDFC facilities. Thank you.